Okay, this is from the end of chapter 1 homework problems. This is question number 54 that someone asked about. So the question is, how many resonance structures can be drawn that have a carbon with a plus charge? So this is the molecule that was given, and I will add in a couple of things here in terms of the lone pairs on the non-carbon, non-hydrogen atoms. So we need to write resonance structures for this and then count up the number that have C pluses. So the way that you would start this resonance structure is to somehow move the a pair of electrons towards the positive charge, because that's how we draw resonance structures for any kind of positive charged species. So I would start by taking this pair of electrons and moving it to the oxygen to now form the oxygen now having a lone pair, and then that would put the positive charge on the carbon that just lost its positive charge to lost its electron to go to the oxygen, leaving a positive charge behind. Now this is going to become a very unwieldy problem if I have to draw out the entire structure each time, but I have no choice. I have to do it that way. Okay, so now we have a positive charge. Can I move any pairs of electrons towards the positive charge and basically make that positive charge a zero formal charge carbon? Yes, I can take this pair of electrons and move it like that. And so if I do that, then I'm going to end up with and then I'm just going to, this will be where the ring is, but I don't need it right at the moment. So now can I move any pairs of electrons towards that positive charge to create a double bond? And the answer here is no, I am done. Because I cannot, if I took this pair of electrons here and I tried to move it there, that there's no positive charge there. Whenever I move a pair of electrons, I have to basically form a double bond where that positive charge was. Because if I tried to move that pair of electrons there, I would end up with a carbon with 5 bonds. So it appears as though there are just 2 resonance structures that the carbon has a positive charge. And that is the correct answer. So whenever we're trying to move pairs of electrons towards a positive charge, those pair of electrons always must go to basically form a double bond, or in this case, give back a lone pair to that oxygen. But you can't move a pair of electrons towards a positive charge unless that positive charge is on the carbon that you're moving to. So in this case, there's only these 2 resonance structures that are possible that have a positive charge on the carbon.